Hello everyone. Last class we covered about uniform motion. Just recall what is uniform motion. If an object covers equal distances in equal intervals of time, so that type of motion is known as uniform motion. If object covers equal distance in equal intervals of time, so this type of motion known as uniform motion. If you remember graphical representation of uniform motion, position versus time, uniform motion. So you should straight line which is passing through origin. So that is the graphical representation of uniform motion. And another type of motion known as non-uniform motion. So non-uniform motion, if an object covers unequal distances in equal intervals of time. So which is known as non-uniform motion. Object covers unequal distances in equal intervals of time. So non-uniform motion graphical representation. So you can take any curve shape. So it's just like a parabola. So distance or position versus time. Or if a car is moving, so like that. So these are the example for non-uniform motion. Position versus time graph. And after that, we come across different types of graphs by using moving man, PHET stimulation, and if object is at rest with respect to position versus time, if the object is at rest, so this is the representation of the graph of the object. So with respect to time, the object is at rest. It's a straight line which is parallel to time axis. So this is the object is at rest. So we come across three different types of the graphs: when object is at rest, when object is in uniform motion, and when object is in non-uniform motion. Today I would like to discuss and to calculate speed and velocity. Speed we define as the distance traveled upon time taken. So as a formula we can write that speed equal to distance upon time. So what speed measures? Speed measures how fast you are going. So that is only it measures the fastness. And it's SI unit meter per second. So because distance we are measuring in terms of meters and time in seconds, speed is nothing but distance upon time. SI unit is meter per second. Just see one small example. If Mary run 200 meters in 40 seconds, what is her speed? So we know the distance 200 meters and time here is 40 seconds. Just divide 200 upon 40. So we got at that 5 meters per second. So that is the speed of Mary. So in the speed, if you are moving in the different intervals, we need to calculate that average speed. Usually we cannot move when we walk or run with constant speed. So average speed we define as total distance upon total time taken. So total distance we are taking in terms of meters and total time also in terms of seconds. So average distance we can calculate by sum of all the distance, total distance upon total time taken. So let us understand the average speed in this given example. Suppose the diagram as shown in below is a runner. Runner is covering different distances in equal intervals of time. So at 9:30 he is already at 10 meters, and at 9:40 it means time interval between at here goes to 10 minutes. So in 10 minutes he covered 5 meters. Oh, it's very slow. Sorry, it's in meter. In 10 minutes he covered 5 meters, just like snail. So next 10 minutes 9:42. So in next 10 minutes again he covered only 3 meter. So like that, if we can take what is the total distance he covered and the total time. So in the first 10 minutes he covered 5 meters. In the next 10 minutes from 9:40 to 9:50 he covered only 3 meter. And next 9:50 to 10 a.m. again in the next 10 minutes he covered 7 meter. So in next 10 minutes from 10 o'clock to 10:10 a.m. he covered 5 meters again, and last 10 minutes he covered 15 meters. So here we are having different distances in 10 each time intervals. So in this case we need to calculate average speed. We cannot calculate speed itself, we need to calculate average speed. To calculate average speed, first we need to sum up total distance. If I sum up total distance, that leads to me 5 meters plus 3 meters plus 7 meters plus 5 meters plus 15 meters. Total distance here is 35 meters. And total time, so here the time interval is 10 minutes. So the total time here is 50 minutes, 50. Now we can apply average speed formula. Average speed equal to total distance traveled upon total time taken. Just divide 35 upon 50 minutes. So to get the result in terms of meter per second, so 35 upon minutes we convert in terms of seconds. So 1 minute equal to 60 seconds. So we got the final result 0.011 meter per second. So this is very slow speed. We should not call him as a runner. So in 1 second he is covering 0.011 meter. So this is just for an example purpose. So this is the way to calculate average speed. Average speed final formula, you can take that total distance upon total time taken. So here I am having one question. If a cheetah can maintain a constant speed of 25 meters per second, it will cover 25 meters every second. So that is the meaning of constant speed. Constant speed. Speed is constant. It means in 1 second it is covering 25 meters. That is the speed. So if that is speed, how far will it travel in 10 seconds and in 1 minute? So this is simplest question. So we know that speed of cheetah in 1 second it is covering 25 meters. Now the question is in 10 seconds. In 10 seconds how many meters it covers? Just multiply that. 25 times 10, it covers as 250 meters. And in 1 minute, so in 1 minute it covers as 25 times 1 minute contains 60 seconds, so it gives us 1500 meters. So this is a very small example. So finally I can say about speed. Speed is nothing but distance upon time, and average speed is nothing but average speed is equal to total distance upon total time. So the next concept, to consider the next concept, let us take this example. Suppose you have a plan to move from your house to your friend's house. So consider it's a rectangular park. So in the rectangular park, one corner is at your house and another corner is your friend's house. Suppose if you chosen this path, so all the way you move from all the way from here to here and again from here to here. So if I want to calculate the speed, so what the speed defines? Speed is nothing but distance upon time. So what is the distance from here to here? So we can calculate from the distance by bringing a meter tape, or if you are having numbers with us, so we can calculate speed. Suppose if you are having more time, instead of selecting short path, now you select a long path. Since you are having time, so you are coming all the way like that. So you are roaming everywhere, every corner, and finally you are reaching your friend's house. Usually this is what happens when we used to go from school to your house. So since we are having time, so we cover all the ways. So by the time what we define speed, so speed also here the distance upon time. Suppose if you run out of time, you don't have time, you selected this path, so all the way straight from there to here. So if you selected this path from there to there, so instead of selecting the path 1 and instead of selecting the path 2, now this path which is selected, the path 3 is the shortest. So this is the shortest path. So the shortest path is also nothing but, here is the displacement. What is the displacement? Displacement is nothing but the shortest distance between initial, suppose this is initial point and this is final. From the initial to final, so this is only the possible shortest path. So this path we define as displacement. Now if we divide displacement upon time, so what that to call? So that is known as velocity. So velocity formula I can give at here, displacement upon time. So to understand the difference between the velocity and speed, speed is a description of how fast an object moves. It won't specify any direction. Speed is a description. It says about how fast an object is moving. And velocity says how fast and in which direction it moves. So velocity is direction dependent quantity because displacement is always having direction. According to definition, displacement is nothing but the shortest distance covered between initial to final point. It is always direction sensitive. So but the speed, it tells about only how fast an object moves, but velocity is how fast and in what direction it moves. So finally you can say that in physics, velocity is speed in given direction. Velocity is speed in given particular direction. Here direction is very important. So let's take an example at here. When we say a car travels at 60 km/h, we are specifying its speed. Here nothing mentioned about direction. It says a car travels at 60 km/h. So we are specifying its speed only. But when we say a car moves at 60 km/h to the north, so here direction is specified. So the specified direction here, it is north. So then it tells about velocity because it's a direction mentioned at here. So that is the difference between speed and velocity. So speed with direction is known as velocity. Finally, we can define a quantity such as velocity that specifies directions as well as magnitude. So those quantities are known as vector quantities. So we define physical quantities in two categories. One is vector, another one is scalar. So what are these vectors? Vectors are nothing but physical quantities, means which can measure, and they should have direction, magnitude and direction. So those physical quantities we call them as vectors. So just like velocity is a vector since it's having direction. Why? Because velocity is a vector, because displacement is a vector. Since displacement, to calculate displacement, we should move in one particular direction. So here we can say, till what we learned in the physical quantities, the vectors are displacement and velocity. And scalar is a physical quantity which do not have direction. So we can say speed is a scalar. So it do not specifies any direction. So now onwards I can call vectors. Speed is a scalar and velocity is a vector. Velocity, force and accelerations, displacement. So on the course of time we will see so many things like that. Especially we will talk about scalars and vectors in the coming chapter. Since at here speed having specific direction, so we can call it as a vector quantity. Along with the speed, the displacement is also a vector. So let us see one small problem so we can understand this better. So finally I can call that velocity equal to displacement upon time. So it's SI units. Displacement also we are measuring in terms of meters and time in seconds. So velocity SI units is meter per second. So let's define average velocity. So just like how we defined average speed, so the average velocity is nothing but the total displacement by total time taken. So be careful when we are dealing with the displacements, because the displacement is direction sensitive. So total displacement, to calculate average velocity, we need to calculate total displacement upon total time. Let us consider a case. So the case is, if you return to your starting point, suppose I started at here, so this is my initial position at x equal to 0. I went all the way in the forward direction 50 meters, and on return I came back. So now this is my final position. So in this case, what is my total displacement? Now my total displacement is 0. So because where I started, there I reached. So if I write that in numbers, so the displacement having direction, now I have to say it is in the 50 meters. On the return it is in minus 50 meters. So because, so on the return, so we have to subtract from displacement is nothing but the final minus initial. So we can calculate that 50 minus 50, the total displacement goes to 0. If the total displacement goes to, in this case, what about that average velocity? The average velocity is also 0, because 0 by time equal to 0. So the displacement we define the shortest distance between the initial and final, and average velocity we define total distance upon, total displacement upon total time. Other than that average velocity, let us define few more, like constant velocity. So constant velocity just we will understand by constant speed. Let us see what is constant. Constant means remains same or steady. Suppose you are running a fan without changing that regulator. So the fan moves with the same speed. So it do not speed up and speed down. So that is something like that constant speed, steady speed. It do not change, it do not move fast, it do not move slow. It always remains, maintains with the same speed. So that is known as constant speed. Similarly, constant velocity also. In the constant velocity, means here we need to consider both. It should maintain the same speed along with the same direction. So if an object is moving in the same speed in the same direction, then we can say that object is moving with a constant velocity. Just get the example, general case example, we can understand it. If a swimmer is swimming in one particular direction with constant speed, so then we can say he is moving with a constant velocity. Now constant direction is a straight line. So constant velocity means motion in a straight line at constant speed. So to maintain constant velocity, the object should move in only one particular direction. If it is not changing direction, it obviously a straight line motion. So if an object is in one dimensional motion in a straight line, so then we can say the object is moving with a constant velocity. So opposite to the constant velocity, so we can say that is a change in velocity. What is change? Change means either change in speed or change in direction. So in the constant velocity, direction doesn't change and speed also doesn't change. Nothing to be changed. It remains as it started, like it is only. But in change in velocity, if either the speed or direction is changing, then the velocity is changing. Yeah, obviously. To change a velocity, either magnitude has to change or direction has to change. So where we can see this case, suppose constant speed and constant velocities are not the same, they both are different. In the constant speed, its only magnitude remains same, but in the constant velocity, the magnitude and the direction also. Let us consider a case. Suppose a body is moving in a curved path or it's moving in a circular path. Even though if the car is maintaining same speed, but in the circular motion its velocity is changing every time. So according to definition of a circle is made up of infinite straight lines. Means if you can draw a tangent on the circle, so that tells about the direction of the circle at the time. So if an object is moving in circular motion, even though it have constant speed but not constant velocity, because here the direction is changing at every instant. So if an object is moving in a circular path, so that is the example for its variable velocities, because it is not having same direction. So we cannot say that it's moving with a constant velocity. So it is moving with a variable velocity, even though the magnitude of speed is same, but the direction is keep on changing when it is moving in circular path. So finally, if we can give the differences between speed and velocity. Speed as a formula, it's distance upon time. It only tells about speed of the body. It's a scalar quantity and speed is always positive. Very careful, speed is a scalar quantity. And when it comes to velocity, Velocity we define as displacement upon time. It tells direction of the body. It's a vector quantity. Since it's a vector, it's having direction. It can be positive and it can be negative. So these are the differences between speed and velocities. Now, if you can go ahead by defining another measuring quantity that's known as acceleration. So I can define acceleration like this. Acceleration is the change in velocity per unit time. Change in velocity per unit time. We can write that in the formula manner. So acceleration A equal to, so acceleration A equal to, you can take that acceleration A equal to change in velocity. It means final velocity minus initial velocity upon time taken. So this in perfect manner you can write that delta V. Delta V means nothing but the change in velocity. Upon time we can write that delta T, small interval of time. Or perfectly at here in the formula we can take that as T2 minus T1, final velocity minus initial velocity, which gives to that delta T. So what is the acceleration we know? So when the accelerator means comes in our mind, so the bikes are having accelerator. So this is the accelerator, and cars also having, almost all the motor vehicles are having accelerator. So it's having, this is the accelerator, brake and the accelerator and the. Now what is the use of this accelerator? Accelerators is enables us to increase or decrease the speed of the vehicle. To give acceleration, if you can give accelerator, what happens? The vehicle speed increases. So that's the meaning of the word accelerator. So when we press accelerator or when we turn accelerator, so what happens? The vehicle speed is increases. So initially, if it is having initial velocity, usually at starting its velocity equal to 0. We can represent that initial velocity always with u, and after time, if the time equal to 1 minute and it reaches to a velocity, let me take that as 100 kilometer per hour in 1 minute. So we can able to calculate the acceleration. Acceleration A equal to change in velocity, means final velocity 100 kilometer per hour minus initial velocity equal to 0 upon time. So how much time is taken to reach from the 0 to 100? So it is given 1 minute. So if you can do this calculation, so we will reach a value, so that is known as acceleration. And remember here acceleration is also a vector. Why? Because acceleration contains velocity. So velocity is a vector. So the formula of acceleration A equal to V minus U upon T. Here V is V indicating for final velocity and U is for initial velocity, and the T is time interval in which that change taken place. So let us understand that's the same example. So I am having a vehicle speed. So initially, so the vehicle speed is at here showing 000. That is the starting. So when the time equal to 0 initial, the speedometer is also showing from the vehicle equal to 0, initial speed is also showing 0. Now I want to check the car how much time it took to reach 100 kilometers. So now here I want to check my final velocity be equal to 100 kilometer per hour. So in this case the timer is showing at here the time taken t equal to 11 seconds. So that is hours, minutes, clock. So it has taken 11.26 seconds. Now how I can measure acceleration? Acceleration equal to change in velocity, final velocity minus initial velocity upon time. So here final velocity equal to 100 kilometer per hour. Initial velocity in this case is 0 upon time equal to 11.26 seconds. So to do these calculations, either we will convert this kilometer per hours in terms of second, so we can do the calculation easily. So what is the number we can get finally? So that gives the acceleration. So this is all about speed, velocity and acceleration. So speed is a vector, speed is a scalar. It do not depends upon direction. And velocity is a vector and acceleration is also a vector. So speed formula we can write that distance upon time, and velocity equal to displacement upon time, and acceleration equal to change in velocity. Change in velocity upon change in time.